next one, you will see this well that has this particular value of productivity index or production indicator. It has a membership of 0.25 in the average wells, and it has the membership of 0.75 in good wells. So this well is partially good and partially average, and the same thing goes all the way. In other words, what we allow to do is we let the wells to have partial membership. What we're saying is there is no magic MCF of gas that makes a well poor or average. It is always a transition. There's overlapping. This is how human beings perform analysis in their mind. This is called multi-valued logic. If that simple idea, let's see what a difference does it make when you do that. So if I use this, the first thing is I'm going to check, see if what I have done makes sense. But I do that by I use 180 days cum gas production as my measure, and that was the x-axis of what I showed you earlier. Based on the analysis, based on the bucketing, if you will, that I made, what you see here, that is for all the wells. So that average 180 days cum gas for all the wells has this value, whereby, given the way I just performed my analysis, poor wells have this much. This is average wells, these are good wells, and these are excellent wells. So as the quality goes higher, so does the 180 days cum. So that makes perfect sense. Now, when you do, this is by design. When you do that, what is the consequences of this on Marcellus thickness? When I use that, although average Marcellus thickness for this data set is this value, then you will see that poor wells have been completed in net thickness of much lower than average wells. So the thickness of the average wells is higher than the good wells than, of course, the excellent wells. When you go to the next well, when you click again, now this is average treatment pressure. And if you remember, when we did this, the average treatment pressure was one big blob. Here, the same data is shown where for all wells, the blue shows a certain value. For poor wells, it shows that poor wells have been completed at much higher average treatment pressure than average wells, than good wells, and excellent wells actually have been. So there is an unmistakable trend that can be seen here. If you go to the next plot, here what you can see is, right now I'm showing the hidden patterns. For example, here what you see in Cartesian, you have on x-axis net thickness of total Marcellus versus best 30 days gas. And then what you do, if the same data, if you click again, now you see it based on this fuzzy pattern recognition for 4, and you see poor wells have much lower net thickness than average wells, than good wells, than excellent wells. And if instead of 4, every single well becomes a category, then you have this continuous formulation, continuous pattern, which actually shows you that as the net thickness, and of course I clicked again, and net thickness increases, so does the total breakdown pressure versus best 30 days gas, and you see no patterns whatsoever. But when you use this fuzzy logic, you will see that all of the data provides you with average of what you see on the left with the background, red background. But then it's very clear that poor wells show a lower breakdown pressure versus average well and good well and excellent well, which average breakdown pressure increases. And if you, instead of 4, if you go all 400 wells, you will see a clear trend that exists. And this is coming, again, this is not a curve fit with any stretch of imagination. This is a fuzzy pattern recognition whereby you take and you qualify the wells and define them as different quality, each one of them, on overlapping clusters. One last thing, this is amount of proppant that is injected versus well productivity. And common sense tells us the higher the proppant you inject, the better well you get. Well, you don't definitely see that in this plot, whereby when you look at the exact same data visualized in using fuzzy logic, you will see that although the average for the entire data set with all the wells, 400 wells, is about 4.5 million. Poor wells have 3.65 million. Average wells have 4.2, and so forth. And you see a clear a very clear pattern, and that is also true when you do it continuously for the entire thing. So in other words, you can clearly see that there is pattern in these data, and all you have to do is to have the right technology in order to, the same thing that I showed you in 2D, you can look at 3D. Here what you can see in x-axis you have TOC of Marcellus, and in y-axis you have net thickness, and then in z-axis you have normalized dimensionless productivity. And you can see these trends. This is when you have fluid volume in x-axis, amount of proppant in y-axis versus productivity in z, and this one is treatment pressure, treatment rate in x and y, and productivity in z. So it is obvious that there are patterns and trends in the data. How can these patterns then be useful to build predictive models?